Okay, so we're looking at the first notes page for statistics, and the first page is just reading. Okay, so I'll read through it and I'll expand a little bit on it. Statistics involves collecting, organizing, and analyzing data for the purpose of arriving at generalizations and making predictions. In our study of collecting data, we will learn the difference between a population and a sample and be introduced to various methods of sampling. Data will be organized into tables, bar graphs, histograms, box plots, and ogives. In analyzing data, we will determine measures of central tendency, measures of dispersion, and percentiles. Okay, so taking a look at the actual collecting of data. So probably back in junior high, you had to do a survey or something like that when you did statistics before. As I said, some of this will be a bit of review. Certainly the measures of central tendency should be calculating the mean should be a review. And so how you collect your data, just need to be aware of different ways of collecting data. If you plan to go to university and take any, like a psych course, a bio course, anything where you might have to collect data or research and get data, then you're going to have to know about the process of collecting it and then calculating all the information, right, to come up with information that might go in a published paper or in a newspaper article or something like that. So suppose you want to, so the difference between a population and a sample. So suppose you want to predict who would win the next federal election. Ideally, you would like to be able to question every Canadian who is eligible to vote. This group would be called your population. In statistics, the population is the set of all people or things that should be considered for the given situation. It is too time-consuming and expensive to be able to question every eligible voter, so a more feasible solution would be to select a sample of the population. That is, a representative portion of the population. The sample would be used to make predictions about the population. For instance, a manufacturer of widgets would like to know about the quality of their widgets. Just so you know, widgets is a word that's used to describe, there is something that's actually is called a widget, but it's really a word that's used to generalize on something that's being made in a factory. Okay, so it could be any item. The population would be all of the widgets that the factory produces, whereas a sampling could be checking every 100th widget that's produced. Analyzing those in that sample would be used to make conclusions about the whole population. So you may have received you may not know, but your family would have received in the last week or so something in the mail to complete the census. So a census is when you ask every person in the population questions, okay? So the Canadian census, they're asking every household in Canada to answer the questions. Some households are chosen at random to answer a small version. Some are chosen at random to answer a longer version. There might be two longer versions, I'm not sure. Mine was medium. It was mostly about what languages were spoken in, well, how many people live in your house, what languages are spoken, that kind of thing, and how old we are. So census is when you actually get information from everyone in the population, but most times you're choosing a sample from the population. So what are the methods for sampling? So since we cannot always survey the population, it's important to select a sample that is representative. One of the best sampling methods is simple random sample. So in a simple random sample, every member of the population has an equal chance of being selected, and each member is selected individually. For example, every student in your class has their name written on an equal sized piece of paper. The papers are then placed in a box and 6 names are selected. So that there's no reason, like if I put all of our names folded up on pieces of paper, except I made mine bigger, okay, then that's not random because likely mine would be chosen. Now, if that was to win a prize, that would be nice, but it would be cheating. So you want an equal chance of being chosen. Looks like there's a question here. Just a sec. Other methods, other than simple random sampling, are systematic sample. So that's where, I remember actually at university we had to do this survey. And so we had a list. This was back in the day where personal information wasn't quite as private. So we got a list of all the students in first year or whatever it was, and we did every 100th student kind of thing. So that's where you choose, you have a list somehow, and you randomly, you go systematically and choose a student every 10th, every 100th. Stratified is where every member of different segments of the population has equal chance of being selected. So for example, if we divide, the example here is school by grade, then it's almost like 3 samples. So randomly choose from the grade 10s, randomly choose from the grade 11s, randomly choose from the grade 12s. Okay, that way, for sure, you're going to get members from each grade, right? So if you're unsure, say alphabetically, the school list, let's say the first half of the alphabet happens to be mostly grade 12s, and you're going every 20th person, you're going to get more grade 12s than the rest, right? Because there's half, whereas it should be really 1/3. So stratified, make sure if you have different types of groupings that you want to include a random sample from. That's different from cluster sampling, where groups are what's random. So you have a bunch of groups and you randomly choose a group and you survey everyone in that group. So that the example that we give here are homerooms. So if we have all of our homerooms, teachers' names, and we randomly sample the teachers' names, then we survey everyone in those particular homerooms. Okay, so that would be what's called a cluster, because you're taking a cluster out to sample. And then self-selected, that's where people volunteer. So you've probably get phone calls at home or in the mall where, oh, will you answer this survey? You know, they'll come up to you in the mall or they'll call you. Can you answer this survey? And you decide to do it, okay? So usually the people that are interested in something will volunteer, okay? So it's not quite as random because you're deciding to do that. You might actually call, like in this example, a TV news show conducts a survey by asking people to phone in with their response. So you're probably not going to phone in if you didn't really care about the question. You are going to call in if you care, and is that really representing the whole population? Maybe most people don't care, right? So self-selected isn't quite as, it's not a good random sample. Convenient sample is where a surveyor picks members of the population that are convenient. So you do a survey, you ask all your friends. So that's not great either. Like think about it, in the old days we used to have, when I first started teaching, school dances. And so there would always be complaints about the music because everyone has their own opinions about music. And so, for example, here, if whoever was deciding on the music decided to survey the school but only chose their friends, sometimes in a group of friends, that's what makes you a group of friends, because you like the same music. So you're not necessarily going to represent the whole population. So that's where you're just choosing the easiest people to survey, your family and your friends, right? Because you need the responses where it's not necessarily representing the whole population. Okay, so now let's get into some of the math. So we went through those. Okay, so first is organizing and displaying data, so frequency tables. So often in statistics, a large set of data is collected. You don't want to have a huge table of values. So you want to summarize it and organize it in a bit better way. So to better analyze the information, the data is usually organized in a frequency table. The frequency is the number of times a particular value or intervals of values occurs. The frequency table can then be represented visually with a bar or column graph for discrete data or a histogram for continuous. So 30 students at Henry Wisewood were asked their age. The data is shown below. So obviously we wouldn't want to have a bar for the first 17, a bar for the second 14, a bar for the 15, because they would all be very close together anyway. So we want to collect the data, 6 different ages, 14 through 19. It's discrete because it takes on only specific values. Can't have part of a person being age 14, right? The data can easily be organized in the, well, vice versa. You can't, if you're 14 and a half, you're still considered 14, right? So it's just discrete data. So we want to count the number of times each of the values occur. So here, next one. So here it is. Basically, I'm going to start with a tally chart. So I just put a little dash. So the first 17, I put a dash, or a tally. Then 14, or you could count through, but you want to keep track. You don't want to miss anything. Okay, so take a few minutes and start preparing your frequency chart. Okay. Okay, so then once you've done that, total them up, your tallies, then total up the total number of frequency, just to make sure it matches. Sometimes you might miss one or have counted it twice. So that's at least you know that you're close, right? I got 30 as my total of frequency, and there were 30 values. And then we're going to do a vertical bar graph or column graph from the frequency table. So it's already started for you. So we want to label. So always, if it's set up like this, you want the frequency in the vertical. Now you can rotate it and show horizontal bars, but the height of the bar has to be the frequency. Okay, so this is the frequency. Okay, notice how the scale has already been done. So the first one's 1. Because my writing is probably a little big for this, I'll go every second. So that'd be 3, 5, 7, 9, 11. And this is age. Oh, and title, that's just the age of 30 Henry Wisewood students. Okay. I'm trying to use my rectangle here. So for 16, it is 11. That's not bad. Okay. And then for, actually, I'm just going to go a little bit left here. And then for 17, it's 7. And 18, it's 4. They should all be equal width. 19 is 1. Oops. That is, that. There we go. Okay. Needs to be a little bit. Okay. Needs to be a little bit wider, but my smartboard is not. So try your best to make them the same width. Mine aren't perfect. But I'm sure you've done bar graphs like this before, so. Are we good? Can I go to the next page? Okay, so next one is continuous data. So when you have data that doesn't have to be decimals, but where you're not having multiple values the same. So the frequency, even in the last one, if we didn't have frequency, say if it was the age of just people, then we probably wouldn't want to do just each particular age. We would probably want to group them. So in this case, a golfer hits 30 balls and the distance in yard were recorded below. So we really don't want to do a bar graph for each particular value because there's really an infinite number. Rounded to the nearest tenth, not an infinite, but still a lot. So this is where we would want to group them in intervals. So we want to group them in intervals. Sometimes they're called classes. In forming groups, find the lowest and highest values, and then make the interval width such that you get about 6 to 12 intervals. Anything more than 12, it's really hard to interpret data from. So in this case, the biggest is 277.5, the smallest is 244.6. I think it looks like they're recorded in order. So the difference is 32.9. So we know 8 goes into 32 about 4 times. So 32.9, a little bit more than 4. So if we make intervals of width of 5, we'll get a good number of intervals. So first interval would have a lower boundary of 240, an upper of 245, and would include the values greater than or equal to 240, but less than 245. Sometimes it will show you what it's less than. In this case, so you'll notice here that this is repeated twice. What this is saying is that highest value is not going to be included in this first interval. So it's really 240 less than or equal to x less than 245. Okay, but in order to prepare a histogram, we're going to have a common side at 245, and that's why it's listed twice there. Okay, so now use the data to complete the table. Probability of each interval is found by dividing the interval frequency by the total frequency. Let's just first start with our intervals of distances. So this would be 255 to 260, 260 to 265, 265 to 270, 270 to 275, 275 to 280. Okay, then let's go with our tallies. So 244.6 is there. They are in order, so you might be able to do it by looking in, just kind of grouping them. 245.1 would be here. Then oh no, they're not in order, sorry. 265.6, so that's going to be here. 272.9. So take a few minutes and go through at your own pace. The 250.0, remember, is going to be included in this one, the third line. Okay, so 1, 2, 6, 7, 8. And then calculate the question. Okay, so the probability, you can just show it as fraction. Reduce it. Total should be 1. If you added up all those fractions, you would get 1, right? Total probability of anything is 1. Okay, so now I'm going to split my screen here. So we can graph it. Started for you. So a histogram can be made using a frequency table of continuous data. A histogram is a vertical bar graph with bars of equal width placed side by side with no space in between. The data values are on the horizontal axis and the frequency in each class is on the vertical. Draw the histogram for the above frequency table Join the midpoints of the tops of the bars to create a frequency polygon and include a title. So we'll do that afterwards. We need to actually make it. So remember here, what are these representing? This is distance. And in yards, this is frequency. And these are distances, a golfer hit, yeah, 30 balls. So, leave it there. So I'm going to try again with my rectangle here. Oh, I do need to label, so I forgot here. I'm going to make this. So 245, 250, 255, 260, 265, 270, 275, 280. And we don't need to go beyond that. And then frequency 1, 2, 3, 4, 5, 6, 7, 8. If you want to label every second, that's okay. For the horizontal though, you should try to label every grid marking. Now I need to do my bars. So 245 to 250 is 3. Mine's not going to be perfect, but it'll be close enough. And then 6. Okay. And then 2. And then 7. This is kind of not so bad. 65, 6. Much easier with paper. And probably with a good old-fashioned way. Okay, so a little bit off there, right? That's the second 6, but you'll have to do. And then 3, and then 2. Right. Okay, kind of close enough. All right, good enough. Okay, then for the frequency polygon, take the middle of the top of each bar and plot a point. And then join those up with a straight line. All I'm doing. Okay. So here to here, here to here, 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 here. Okay, so if you join those, say, with the x-axis, straight line down, it would form a polygon, straight sides. Okay, so that's something that you may not have heard of before. Then, for probability distribution, okay, so that is a histogram where the vertical axis is the probability of each class. It asks you to draw it here. Okay, I'm going to leave this for you to do. Notice that this axis will be the same, and this is going to be distances, yards. This is going to be probability now. Okay, so, and it's giving you the scale here. So if one grid marking is 0.05, then the next one would be 0.1, 0.15, etc. And I'm going to leave this for you to do. It's going to look very similar to the histogram. Okay? Only thing that would be different is, so the ratio of the graphs are going to be the same. Okay? If you think about what the probability of 1/30th is, so on your calculator, so probability is 1/30th. What is that as a decimal? Is 0.03. So that value there, underneath that height there, is 0.03 repeating, really. So if that was the same height as this, the graph would be exactly the same. It's not. The scale on this is a little bit smaller, but the ratio of the heights of the rectangles would be the same. Okay? So just be aware of that. Okay, now, same thing with the TI-83 directions here. Oops. This is directions on how to make a histogram. This is just for your interest's sake. You're never going to be asked to make a histogram on your calculator because it really doesn't do anything. Like, yeah, you can't really do anything with it. So it's nice to look at, but one that's made by hand is way more descriptive because you can actually see the axes, vertical and horizontal. So I'm just going to leave this for you to do. Okay, sort of for fun. Basically, it's nice to know all the options of things in your calculator. There's so many things in your calculator. I don't even know how to use all of them, but this is kind of neat for you to look at. Okay? There will be stuff that we will do with your calculator, but not that. Okay, so I'm going to stop the video on this one.